So very good afternoon guys, welcome back to Chandu biology class. So in this class we will talk about the physics part, that is kinematics. Okay. So until now we have studied about the units and dimensions, measurements and errors, and then basic mathematics. So from this class we will start with the kinematics part. So when we talk about the kinematics, kinematics, like we are talking about the motion of an object. Okay, suppose a bus is moving with velocity 10 meter per second, we'll talk. Okay, but we won't talk about how the bus starts and how they started moving, like who started pushing the bus, and we won't study about how the cause of the motion. Okay, we'll just talk about the motion. So here we talk about the motion, but we don't talk about how the motion has been taken place. We won't talk about how the motion has been taken place. Okay, this is the main important point in kinematics. We will talk about the motion, but we won't talk about how the motion has been taken place, like who pushed, who have been pulling, those things we won't talk. Okay. So first topic we will see what is the reference point. You understood now the points, this one kinematics. So we will go for the reference point now. First topic, reference point. Okay. Suppose how we can say object is moving or object is at rest? Like how we can say object is moving and object is at rest?
With respect to its surroundings.
Like with respect to its surrounding. With respect to its surrounding means, like if I take a person A, person B is running with some speed. So I can say person B is running with respect to person A. Okay, let me take an example here. A person is there, B person is there, and C person is there. Okay, E is moving with velocity 5 meter per second, and these are at rest. V is equals to 0, V is equals to 0. Okay. Suppose if I talk about A and B, only A and B. So with respect to A, B is moving. With respect to C, B is moving. But with respect to A, C is at rest. How we can say at rest? Because the position is not changing, right? Position is not changing with respect to time. The first point we can say is position and time. If position changes with respect to time, I can say object is at motion. Okay. The same like one more person I will take. Person D is moving with 5 meter per second. Okay. Now I will talk about B and D. What we can say about B and D? They are at rest because they are moving at equal speed and the distance between them are equal. It is not changing. Okay, it is not changing. If I take the speed as different, this like the distance between them changes. It means the position changes. Okay, so if position changes with respect to time, I can say it is motion. The third point is if position doesn't change with respect to time, it is rest. So with respect to surroundings only we can say object is at rest or object is at motion. Okay. By surroundings we say the both motion and rest. Any doubt in this? So by this example we can say object is moving or at rest. Okay. And one more thing is we should keep in mind position changes with respect to time, motion, position doesn't change with respect to time, it is rest. Okay. I will give one more example here. A person is standing and one more person is sitting in a train. Train is moving with some velocity. Okay. So person A, let me take with diagram. This is the person A moving with velocity 5 meter per hour, okay, 100 meter per second. This is train. Okay. Person A is sitting there. Person B standing outside and watching. So according to person B, person A is moving with 100 meter per second. Okay. Now let me take one more thing. Person A, person B. Okay. A and B. This also moving with 100 meter per second. One more person is standing, person C. Okay. And the third example is two persons are, okay, let me take only one person. One person is there and one more person is standing outside. It is at rest. Okay. The third example, a person is tossing a coin. Okay. It will go straight and come back. According to person B, if we see the coin, what we can understand? A coin is in motion, but it is in straight line. No, straight line. So in this we can say it is inertial frame. Inertial frame is nothing but when a person is observing another person, but that person is not moving, but that person is tossing some coin, okay, without accelerating. Okay. Here the train is not moving, no. So not moving in the sense there is no acceleration, first thing. And if we toss a coin, it will go straight and come back in the straight line. But in the second example, okay, a person is tossing a coin. Person A is tossing a coin. Person C is watching. What we can understand? Will the coin will go straight and will come back to the straight?
No, sir.
Why?
With respect to C, it will move in the direction of A to B. But if we look at from the perspective of A, it is a straight line.
Okay. With perspective of A, it is a straight line. But with perspective of B, I mean C,
it is moving.
like I can say that it is going in a parabolic path.
Yes.
Like if I toss a coin like this, buses or train is moving like this. So if I toss like this, I will move front. The coin will come down with the straight line. But according to person A, it is straight line. But according to person C, it is in parabolic path. Okay. This one I can say as non-inertial frame. So inertial frame means it is not accelerating. Non-inertial means it is accelerating. Okay. The main thing you should understand is inertial frame, not accelerating. Non-inertial is accelerating. Here we can observe the straight line, right? Here we can observe the parabolic path. Like it is going like this and coming in the direction. But person A, with respect to person A, it is in the straight line. With respect to person C, it is parabolic path. Any doubt in inertial and non-inertial? So both difference are accelerating and non-accelerating. Okay, that's it. Now, if I talk about the position, okay. So we are going to talk about the three things. One is one dimensional, two dimensional and three dimensional. One dimensional means like position of a object changes with respect to time in only in one direction. It means one dimensional. When the position of an object changes with respect to time with two coordinates, like one coordinates means one dimensional, two coordinates means two dimensional. Like I will say here, one dimensional is nothing but a straight line. Okay, straight line, either front or back or up or down. Okay. Two dimensional means it's a plane. Okay. Circle we can take, parabolic path we can take. Okay. It's a plane. Three dimensional means space. Okay. This is a three thing. So the coordinates are x, y and z. Okay. AC remote. Okay. So one dimensional it is a straight line, two dimensional it is a plane, three dimensional it is a space. So when we are talking about one dimensional it is one coordinate, two dimensional is two coordinates, three dimensional is three coordinate. Okay, this is the main thing. Okay, one coordinate, one dimensional, two coordinates, two dimensional, three coordinates, three dimensional. Okay, so if I take an object in a space, space in the sense in coordinates I am taking. Okay, x, y, z in a space. So let me take this as x1, y1, z1. Okay. So whenever I am considering a position of an object, I will consider with respect to origin. Okay, with respect to origin I will consider. With respect to origin means x1 minus 0, y1 minus 0, z1 minus 0. Okay, with respect to origin I will consider. So position I will name it as r. Okay, r I will name it. So position is named as r, or let me name it as x. Okay, displacement, position, velocity. Right. So I will name it as r. Here I will take one more position of the object, that is r2. Okay. This is 0, 0, 0 which is origin. So r2, x2, y2, z2. Okay. I have taken two position. Okay. First position is r1, second position is r2. If I consider from r1 to r2, position changes. It means some displacement happened, no? Some displacement happened. So what I can say now? Position means we know, right? Like I need to locate some object with respect to origin, that is position. Displacement means change in position with respect to change in position is nothing but displacement. Yeah, with respect to origin it has been changed. Okay, so change in position is nothing but displacement. First thing, it's a position, you understood. Second point is displacement. Change in position. That's enough. Change in position is nothing but displacement. Any doubt here? So first we have seen what is kinematics, second is inertial non-inertial frame, third is position, and fourth one is change in position is nothing but displacement. Okay. So displacement is denoted by the letter S. Okay. Now here the formula is S is equals to final position minus initial position. Is said to be displacement? No. Initially I am standing from one point, I am moving to another point. It means final position minus initial position. So what is final position? x2 minus x1 for x coordinate. For y coordinate it is y2 minus y1, z2 minus z1. Is there any doubt? So I am like displacement is nothing but change in position. Final minus initial. I will write it here. Final position minus initial position. This is the formula for the displacement. Any doubt? Can we do a problem in this? Okay. Let me tell the problem. If a particle moves with, you will note down. Okay. If a particle moves with, moves from x1 is equals to 4 meter and x1 equals to 4 meter and x2 equals to 12 meter. What is the displacement of the particle? x2 minus x1. So x2 is 12. So it is 8 meters. Okay. So the unit of displacement is meter. So unit is meter. Okay. So it is total 8 meter displaced. So now we will talk about what is distance now. Displacement we have talked, like change in position. Okay. Distance is the total path covered by the object. Okay. The main difference between the distance and displacement are distance and displacement. Okay. Distance and displacement. So the first thing is distance. Distance is nothing but total path covered by the object. Displacement is shortest path. Okay. Total path covered by the object. This is distance. The displacement is nothing but shortest path covered by the object, or we will say particle, anything. Okay. So one more thing is distance is a scalar quantity. First point, this is total path. Second point, it is scalar quantity. What is scalar quantity? It has only magnitude, no direction. For displacement, it is a vector quantity. Both direction and magnitude is there. Okay. The important point is displacement is less than or equals to. It will be less than or it can be equal to distance. Why it is less than or equals to displacement, distance? Suppose I am starting from point A moving to point B. Let me take here point A, B, C, D. A, B, C, D. Square I will take. So this is 2 meter, 2 meter, 2 meter and 2 meter. So what is the distance covered by the object from point A to point D? Point okay, point A to point D it is 6. So point A to again point A it is 8 meter by for the distance. For the displacement is nothing but change in position, right? I have changed the position, again changed the position, again I have changed the position, I came to the initial position. So when I talk about the final thing, is my position changed? No. So it means displacement is 0. If position is not, like I have moved but I came to the original point. So when I coming to the original point, I will say that displacement is 0. Okay. The important point is, note point, when I start from some point P and moving, okay, and coming back to the same point P. It means displacement is but what about distance? Distance will not be equals to 0, right? Distance will not be equals to 0, right? So for example, from Hyderabad to Vizag some x kilometer is there, again from Vizag to Hyderabad some x kilometer. So x plus x 2x. So distance will be 2x, but the displacement is 0. Okay. Any doubt in this? So when I talk about the displacement, I should consider about the direction also. When I am moving, so simple thing, take the axis of the coordinates. You know that x, this is minus x, y minus y. When you are moving from origin to x direction, it is positive, minus x is negative, upward it is positive, downward it is negative. If you keep in mind this one, you can do the displacement problem easily. Okay, I will give you some here, you can do now. So here the diagram is given like this. It is 1 comma 0, it is 5 comma 0. So this is 2 meter, 3 meter, 2 meter. So can you find what is distance and displacement in this? Can you tell what is displacement and distance from this? This is y and this is x.
Distance will be
Find distance and displacement. Give the answer.
distance will be plus 7 meters.
Hmm.
It will be total distance now.
So distance is
7 meters.
7 meters. From this point I am starting. Okay. So 2 meter, 3 meter, 5 meter plus 2 meter, it is 7 meter. Okay. So distance will be equals to 7 meter. What about the displacement? I need to go from this point to this point. I don't need about the path travel. I need only the shortest point, right? So what will be the answer?
x2 minus x1
This is
finally
final and this is initial. So 5 minus 1, 0 minus 0. So total is 4. So displacement will be 4 meters. Okay, 4 meter. So if I talk about the distance and displacement, no, displacement is less than or equal to 7, right? So the thing we got, displacement is less than or equals to distance. It means 4 less than or equals to 7. Right? Any doubt here? We'll go for next thing. So next topic is velocity. Okay. We talked about position. So change in position is nothing but displacement. Now the velocity point. So change in displacement with respect to time is nothing but velocity. Okay. Velocity and speed. Okay, speed and velocity. Now if I talk about the velocity, change in position with respect to time. Change in position is nothing but displacement. Change in position with respect to time is nothing but velocity. Okay, change in position with respect to time, like displacement by time. No, change in position is nothing but displacement. So with respect to time, if I talk, it is velocity. Okay. What about speed? Distance by distance by time. Now if I talk about velocity and speed in a scalar or vector, which one is scalar and which one is vector? Speed will be scalar because we are talking about distance, only the magnitude point. When we talk about the displacement, it is both magnitude and direction. Both magnitude and direction, right? So this is vector, no? And this one is scalar. Okay. So average speed means total distance travelled by total time taken. So average speed. Average in the sense I am taking everything and divide by the total number, no? So total distance by total time. Okay, this is about the speed velocity. Okay, when I talk about the velocity, it is a vector quantity. We'll denote it by like this, V cap or V bar. Okay, when I take the modulus, it will be speed. Modulus means only magnitude, no. So if I talk about V is equals to 3I cap plus 2J cap, this is velocity. Okay, velocity. I'll talk, like, let me consider this velocity. If I talk about the speed, speed is nothing but modulus of that. So under root of 3 square plus 2 square. That's it, no? So which is nothing but 9 plus 4, it is root 13. Any doubt here? So when we take the modulus of the vector, I'll get the speed. Okay. Next is instantaneous velocity. Okay. Instantaneous velocity. So instantaneous velocity is nothing but, suppose you are going in a bike. Okay. So going with 120 km per hour, you are saying. Okay. Suddenly you are watching the speedometer. If you seeing the speedometer, you are noticing some speed. At that moment, what is that speed you are saying? That is the instantaneous velocity or instantaneous speed, we will say. Okay. At that particular moment, what is the velocity? Understood? So when we talk about the velocity, I am talking about the whole path, right? Whole path travelled by the object, or the shortest path travelled by the object. But instantaneous means at that particular moment, what is the speed? Understood? Any doubt? At that particular moment. Okay, at that particular moment. So when we talk about the formula, no, V is equals to dx by dt. Dx by dt. This is the instantaneous formula. If equation is given, okay, like x is equals to 3t square plus 2t. Okay, x is equals to 3t square plus 2t. Find the velocity at t is equals to 3 seconds. It means what I should do? I should differentiate that. At 3 seconds they are asking, no, I should differentiate that. Differentiation means what I will get? 60 plus 2. So if I need to substitute the value of t here. So what I will get? 6 into 3 plus 2, which is nothing but 18 plus 2 is 20. This is the velocity at that instant. Suppose the same equation is given. What is the velocity of the object travelled from t is equals to 0 to t is equals to 3? Can you do this one? This is, they are asking about the average velocity. T is equals to 0 to t is equals to 3 seconds. This is at t is equals to 3 seconds. So when you are talking about this one, no, t is equals to 0, t is equals to 3, what I should do is first substitute 3 is equals to 3 in the same equation. No need to differentiate. What I will get? 3 into 3 square plus 2 into 3. Okay, this is position. So this is position at time t is equals to 3 minus at position time t is equals to 0, 3 into 0 square plus 2 into 0 divide by the total time is 3 plus 0, no, 3 plus 0, which is nothing but as 3 minus 0 will come, like change in time, no, change in position with respect to change in time. So what is this? 9 into 3 is 27 plus 6, this is 0 totally, divide by 3, which is equals to 33 by 3 equals to 11 meter per second. This is 20 meter per second. This is V instant. This is V average. Any doubt in calculating V instant and V average? If equation is given and time is mentioned like this, at t is equals to 3 means I should talk about the instantaneous. At t is equals to 0 and t is equals to 3 means I should talk about the average. Okay, any doubt? I will give a problem here now. Yeah, you can take the problem. A body covers, I will also write that. A body covers 1/3 of a distance with 1/3 of a distance. Like there is total distance is there. So 1/3. So it has been divided into 3. So 1/3 of a distance with v1 velocity. The second 1/3 means the second part with v2 velocity, and the last 1/3 with v3 velocity. Okay, now I need to find the average velocity. Options are given as v1 plus v2 plus v3 divided by 3. This is option A. Option B is 3 v1 v2 v3 divided by v1 v2 plus v2 v3 plus v3 v1. Option C is v1 v2 plus v2 v3 plus v3 v1 by 3, and the option 4 is v1 v2 v3 by 3. Can you find the average velocity? Here the distance, total distance is there. Distance has been divided into 3 parts, equal 3 parts. It means d by 3, d by 3, d by 3. Okay. Now I need to find the velocity, average velocity. Average velocity means total time by total distance by total time, no, or total displacement by total time we will say, right? No. So like displacement is changing, yes, no, like this, the displacement has been given here. Now I need to talk about here. This one understood, no? The question you have understood. So let me talk here. So average velocity, V average they are asking, no? It means V1 plus V2 plus V3 divided by T1 plus T2 plus T3. I know only V1, V2, V3, d by 3, d by 3, d by 3 they have given. There is no T1, T2, T3 part. What I should do first thing? Find T1, T2, T3. We know the formula, velocity equals to displacement by time. So T1 equals to d1 is d by 3, d2 is d by 3, d3 is d by 3. So T1 will be equals to d by 3 by V1. What about T2? D by 3 by V2. T3 will be equals to d by 3 by V3. Any doubt here? So now I can substitute the value of V1, V2, V3 here, no? I can substitute, no? Now what I will get?
V1 plus V2 plus V3 by d by 3V1.
So this is distance, no? D1, D2, D3, no? Displacement by time, no? So displacement by time. So D1 is there. D1 is nothing but d by 3 plus d by 3 plus d by 3 divide by, what is T1, T2, T3? D by 3 by V1, yes, no, plus d by 3 by V2 plus d by 3 by V3. I will keep as it is. I will take d by 3, d by 3, d by 3 commonly outside. What I will get? 1 plus 1 plus 1 1 by V1, 1 by V1, 1 by V1. So I am taking commonly d by 3 and cancelling out. So 1 plus 1 divided by 1 by V1 plus 1 by V2 plus 1 by V3. Any doubt? Now I can solve, no, by using LCM. So first I will do first these two LCM. What I will get? This is 3, no? Upper part will be 3. So V1, V2 cross multiply. What I will get? V2 plus V1 divided by V1, V2 plus 1 by V3. Again cross multiply. V2, V3, V1, V3, V1, V2. Yes, no? So 3 by V2, V3 plus V1, V3 plus V1, V2 divided by V1, V2, V3. Any doubt? Now what I can take this up, this total denominator part. Now I will take that to the numerator. So 3 V1, V2, V3 divided by V1, V2, V2, V3 plus v3 v1. This is my average velocity. So if I see the option, which option is correct? Option B. Any doubt now? Any doubt? Understood now? If you want, you can take that. You can take the formulas. So whoever watching now, you can take the screenshot of this. Over. We'll go for the next part. So we completed position, displacement, velocity. Now the thing is, acceleration is left out. So the acceleration is nothing but change in velocity with respect to time, like rate of change of velocity with respect to time. Okay. So acceleration. So acceleration is nothing but rate of change of velocity with respect to time. Okay. So for what is the unit of velocity? Meters per second. Okay. So unit is meter per second. Okay. Now if I talk about the acceleration, no, what will be the unit? So it is change velocity by time, no. So velocity by time in the sense meter per second, which is nothing but meters per second square. This is the unit. Okay. So acceleration is nothing but A is equals to change in velocity by time. Okay. So this is acceleration. So if I talk about the instantaneous acceleration, no, this is also at that instant, particular instant, what is that acceleration they are asking. So it means A will be equals to dv by dt. This is instantaneous at that instant. Okay, at that instant. So acceleration we know, instantaneous acceleration also we know, like dv by dt. So one more trick I will say here, when position is given, if they are asking about acceleration, okay, like position is x, v is velocity, a is acceleration. So equation will be given, no, like x is equals to 3t cube plus 2t square plus t. This is the equation they have given. Find the acceleration of the particle at t is equals to 2 seconds they are saying. Find acceleration at t is equals to 2 seconds. So it means what I should do, position they have given, I need to find the equation of the acceleration. First if you differentiate, you will get velocity. So second differentiation you will get acceleration. So I need to differentiate position to velocity, differentiation, velocity to acceleration, differentiation. If you are coming in the reverse, integration. Any doubt? So if I take the question, what will be the answer for the acceleration? So first, like v is equals to dx by dt means velocity, right? So what I will get? 9t square plus 4t plus t will be 1, right? Correct? No. If I differentiate t, it is 1. Now for acceleration, it is dv by dt. So this is the equation of v now. Now what will be the answer? 18t 18t plus 4, that's it. No, now if we substitute the value of 2 here, 18 into 2 plus 4, which is nothing but 36 plus 4, 40 meter per second square is the acceleration. Any doubt? Can find easily, no? Right? No? Now take, I'll say the questions now. The first question, okay, the position of a particle moving along x axis is given by x is equals to 5t square minus 4t plus 20. 20 meter, okay, where t is in second. Okay, find average velocity between 1 second and 3 second. First question, average, in this first part is average velocity between t is equals to 1 and 3 seconds. Second part is find the velocity of a function of time at t is equals to 3 seconds. They are asking, second part is at time t is equals to 3 seconds. Third part is find the acceleration. Find the acceleration at time t is equals to 2 seconds. Understood? Now fourth part, when the particle is at rest, when the particle is at rest, these are the 4 points. Okay, these are the 4 points, like 4 questions they have asked from the equation. So for the first, what is the answer? Average velocity. What I should do? Substitute value of 1 and 3 in the equation, divide by the change in time. Change in position with respect to change in time only, no? Like velocity. Then
for velocity we have to do differentiation.
First I need to differentiate, substitute the values. First thing, no need to differentiate anything, directly substitute the value and get the position. So divide by time, you will get the average acceleration, like velocity. At t is equals to 3 means I need to differentiate this one. So at that particular time, what is the velocity they are asking? What is the acceleration?
Then we have to do
Double differentiation. Fourth one,
when the particle is at rest,
particle rest means what it means?
that it's not moving.
It's not moving. So velocity equals to
0.
velocity 0, no. So take the equation, differentiate it, you will get the velocity equation, right? Velocity equation. So velocity equation should be equals to 0. Velocity is 0, right? V equals to, you will get some equation. What is the equation? 10t minus 4 you will get. So 10t minus 4 should be equals to 0. Velocity 0. So I can take that equation to 0. So what they are asking, when the particle is at rest, when means at which time they are asking, no? So I can find the time from that equation. So that is the time the particle is at rest. Okay. Can you give the answer for these questions? Yeah. Guys, whoever watching in online, no, you also can give answer for this 4 questions. Average velocity between 1 and 3, instantaneous velocity and acceleration at time t is equals to 2 seconds when the particle is at rest. You can give answer. Completed? So what is the answer for the first question?
First question.
So A will be equals to, first I need to substitute value of 3 and 1, no? So what will be at x3 will be equals to 5 into 3 square minus 4 into 3 plus 20, which is nothing but 45 minus 12 plus 20, which is equals to 65 minus 12, 53. X1 equals to 5 into 1 square minus 4 into 1 plus 20. So 5 minus 4 plus 20 equals to 21 meter. This is 53 meter. So velocity, average velocity, no? Average velocity equals to x3 minus x1 by t2 minus t1. So keep in mind simply delta x minus delta t for average velocity. dt minus dx minus dt is instantaneous velocity. Okay. So what will be the answer? 53 minus 21 divided by 3 minus 1. 53 minus 21 is 32. Okay. 32 by 2, which is equals to 16 meter per second. This is the average velocity, right? What about the instantaneous answer for the second one, no? V instant should be equals to. So I need to differentiate that equation. What is the differentiation of that equation? 10t minus 4. No? At t equals to 3. So 10 into 3 minus 4, which is nothing but 30 minus 4 is 26 meter per second. This is the answer for the second question. First question answer is 16 meter per second. Second one is 26 meter per second. What about the third one? Find the acceleration. No. Find the acceleration at time t is equals to 2 seconds. So equation is x is equals to 5t square, no? 5t square minus 4t plus 20. So v equals to 10t minus 4, a equals to 10. So when I see here t is not there. They are asking about t is equals to 2 seconds. No. So when I see only constant is there, 10 is there. So I can say it is a constant acceleration. It is not changing with any time. So 10 meter per second square is constant throughout the motion. Okay. So A will be equals to 10 meter per second square, which is constant throughout the motion. Okay. What about the fourth one? V is equals to 10t minus 4. 10t minus 4 equals to 0. So V equals to 0. These are the two equations. So 10t minus 4 equals to 0. T equals to 4 by 10, which is equals to 0.4 seconds. Yes, no? This is the time. So any doubts in these questions now? Any doubt? Is it clear about acceleration, velocity, displacement, everything? Okay. So in next class we will start with kinematic equations, but before going into kinematic equation we will solve some more problem in this. Okay. Yeah, we can wind up now.